Our next presenter is Arnel Orig. Arnel retired from military service in 2004 after 21 years of service as a U.S. Navy diver and special operations technician. After that, he had another 21 years of working in information technology and recently retired as an IT manager before joining the MAS NBC program. I don't want to give Arnel's story away because it's an important part of his presentation, but I do just want to say that Arnel came here with so much purpose, so much intention, and his positivity has been consistently just infectious. I think every time I would see him in the summer and say, oh, you know, Arnel, how's the summer going? Every day was the best day of his life. Every day he was living a dream, sometimes maybe even tearing up with emotion because it was just such a powerful experience that meant a lot to him. So I'm just so grateful, Arnel, that you found your way here. And really, your positivity has just been infectious. So your impact on the cohort is just been invaluable. And the name of Arnel's presentation is Sea Cucumber Aquaculture at Kaua'i Sea Farm. Welcome, Arnel.
This is not the pier that you're seeing now. This was taken in 1983, the old wooden scripts pier. And this is my story. July of 1983, when I first stepped on the Scripps campus, this was right after boot camp here in San Diego, now the Liberty Station. Yes, I've come full circle. I told myself I'd be back here someday to pursue my dream of being a marine biologist. Surprisingly, I found out that in this very picture, this photo, where I was standing by the old Southwest Fisheries Center sign, the Marine Conservation Training Facility was built. So 40 years later, I was somewhere in that very same spot. Fast forward to 41 years later. I'm here at Scripps presenting my capstone project on sea cucumbers of all ocean creatures. You're probably wondering why. Well, it was one of these high school biology class trips back in the Philippines that I had to build a glass bottom box so we could go to this field trip and observe marine invertebrates on the sand. We were not allowed to snorkel, just to observe. And I found this black sea cucumber and I picked it up, and that was the most fascinating thing I can remember back in the high school days. I worked at the Nomilo Fish Pond in Kaua'i for about a week last April, while I learned from Dave Anderson, an alumnus of this program, class of 2016, and how seawater exchange happens naturally during the rise and fall of the tides. There was a gate that would let the small fish in, and when they had grown, they could not leave the pond because of the gate's mesh screen, or what they call makaha. Kaua'i Sea Farm is its own second year of a federally funded project to promote and restore native Hawaiian sea cucumbers. Since they have not done any sediment analysis, I decided to make this my capstone project. The most important ecological role of sea cucumbers is sediment processing. They clean up organic rich sediments through the tubes of their mouth openings, which are excreted as feces, helping in nutrient recycling. The waste produced by sea cucumbers is rich in nitrogen and other nutrients such as phosphates. The sea cucumbers at Kaua'i Sea Farm are kept in continuously aerated holding tanks for spawning and reproduction. Most sea cucumbers are scavengers that travel along the seafloor, feeding on tiny particles of algae or microscopic marine animals using the tube feet surrounding their mouths. These particles are ground down into smaller pieces, which are further decomposed by bacteria. thus become part of the nutrient cycle, just like earthworms. Sea cucumbers keeps the ocean ecosystem healthy and prevents ocean acidification. This is an underwater video that I took, very close up of a sea cucumber, Actinopago varians, foraging and consuming anything they can grab on the bottom, just like a vacuum cleaner. That's actually the noise coming out from underwater, from when they're moving around. Sediment processing is one of sea cucumbers' most important roles, just like I said earlier. They ingest detritus in organic waste and excrete it after absorbing all the nutrients, such as bacteria and macroalgae. Yes, the sand, when excreted as sea cucumber poop, is actually cleaner since most of the organic matter has been consumed and digested. With the help of Dave and his crew at Kaua'i Sea Farm, we installed the cages near the shore during the high tide mark of the day. They were stabilized with 3 metal posts per cage. And after that, back at Scripps, sediment samples were transferred to crucibles and weighed before drying and desiccation. There were 3 replicates per sediment sample as marked. For example, cage 1 inside, cage 1 outside had a total of 6 crucibles that were tested and analyzed. The drying process takes 48 hours to complete at the sediment analysis lab. Samples are dried at 60 degrees centigrade for about 2 days, put in the desiccator, and then weighed again. Loss of ignition, or LOI, calculates the percentage of organic matter by comparing the weight of a sample before and after the sediment has been ignited. The ignition is at 500 degrees centigrade for 4.5 hours. So that's me. I weighed samples after loss of ignition to obtain the ash weight. Before ignition, the sample contains organic matter, but after ignition, all that remains is the mineral portion of the sediment, mostly small rocks. To calculate for percentage organic matter, the weight of the dry sediment minus the weight after loss of ignition, or the ash weight, in grams. This difference multiplied by 100 is divided by the dry sediment weight in grams. A second set of samples was collected on May 15th after sea cucumbers were removed from their cages. The sediment samples were analyzed and completed on May 20th, again after 72 hours of drying, desiccation, weighing, and baking. After sediment analysis, I also compared the texture of the feces, that's on the right, versus the actual sediments collected in the cages. The feces collected were excreted by the sea cucumber while in the transport bucket shortly after being moved back to the holding tank. Three replicates for each sample were tested and analyzed for samples collected on April 8th and May 15th. On the left side, that's the April 8th collection, and the samples were averaged and compared for the loss of organic matter after 5 weeks of the sea cucumbers being in the cages. So in conclusion, there was a marked decrease of percent of total organic matter after 5 weeks when the sea cucumbers were kept inside the cages. And the assumption was that sea cucumbers were able to consume organic matter during that 5-week period. And lastly, the percent total organic matter after the 5-week period showed varied results from 3 replicates of the same sample inside and outside the cages. So based on this, I recommended a second sediment analysis to include sulfide content, since the pond is an old, inactive volcanic crater, and an analysis of the sediment at the pond's deeper end, or the center of the pond, and lastly, the sea cucumbers could be held in closed cages under the clams that's being raised at the sea farm. And as a deliverable, I made a story map as a science communication tool, and here it is. I showed a little bit of the Namilo fish pond and its historical significance. I also emphasized the traditional knowledge and historical significance of the fish pond and its modern relevance right now as a living classroom and a teaching facility. This is the first shot that I took coming down from the hill, traveling to the Kaua'i coffee plantation. And as you can see, I can see the actual channel from the top of the hill. More pictures. This is the floating dock where they're racing clams right now. So they're kind of going to the integrated multi-trophic scenario. The channel, that's the gate that I was telling you about earlier that holds the fish inside. And the channel that was created a long time ago. The mouth of the pond. And let me see what's the next one. Well, I also took some pictures of the close pictures of the gate, because I was really amazed at how they were actually able to keep the fish inside with that low mesh gate. And this is a little bit more about the sea cucumber efforts at Kaua'i Sea Farm. My deployment of the cages to start my experiment on the April, and the 3 species of sea cucumbers that I used for this experiment. And that's the sea cucumber poop with the nudibranch on top of it. And my story map also shows a little bit more about the results and the actual sea cucumber mass after the experiment, and my conclusions and the recommendations. And those are the owners of the Kaua'i Sea Farms. I'd like to thank my Capstone Advisory Committee. Thank you to Kat Montgomery, my chair, from ESP Advisors, Dr. Greg Ross from Scripps, Ana Pauline de Guia, yes, my sister, from the University of the Philippines, and Corey Ridings at Ocean Conservancy. Thank you to Dave Anderson at Kaua'i Sea Farm for helping me out during that week I was out in Kauai, and his crew. To Mr. and Mrs. Taylor, the owners of Kaua'i Sea Farm, and to Carlos Nera for helping me with my sediment analysis. And lastly, everybody here at Scripps, my cohort, all my professors, thank you very much. I really appreciate this wonderful learning experience. Thank you. And any questions? I'll try to answer them as best I can. Yes, Kat.
Great presentation, Arnel. I'm curious if there was anything that surprised you about the results of your sediment analysis study. Yes,
I was surprised with the the results of the sediment analysis were the total percent organic matter. I mean, I just kind of like, oh wow, they are really consuming organic matter. And after comparing it with the actual sea cucumber poop that we were able to get from the transport, it just luck, you know. Comparing that was actually the same as the results from the May 15 after the sea cucumbers were removed from the cages. So that was like, okay, this is really nice to have this kind of results.
Hi, Arnel.
Hi.
I loved hearing your story, and it was a wonderful presentation. I just had a question. Are they keeping the sea cucumbers at the farm to maintain the health of the farm, or are they actually harvesting them for people to eat as well?
So right now, they're not keeping the sea cucumbers inside the pond for two reasons. One is they know there's sulfide in the pond, and for a fact, also they are only federally funded. They can only keep up to 13 sea cucumbers in the holding tank. So the idea is to have a hatchery production to actually raise the sea cucumbers inside the farm so they can use it in the pond to clean up the bottom. But right now, they're still in their second year of a multi-year funded sea cucumber aquaculture project.
Great. Thanks so much, Arnel.